In this video, I will try to show how VLANs could help to reduce broadcast domain. That's one of the main reasons for using VLANs. So first, we should define what broadcast domain. And a broadcast domain is all the computers and devices that are connected and will receive a broadcast message. So let's draw a network with lots of different connected switches, and we'll show how broadcast message arrive to all the computers connected to different switches. So let's use several computers connected in those different switches. For example, and we will connect all the computers. So let's go, never mind the where we are connecting the devices, because we only want to check that broadcast messages spread all over the network. That could be, I will hide preferences. I will hide the port labels because now they are not needed. Okay, this could be one topology, and we will define just the IP addresses in just two computers. For example, the PC0 and the PC1. And the PC6, for example, and we will use just one network address. Let's say it will be 10.0.0.0/24. So in the PC0, we will define one IP address, for example, 10.0.0.10.255.5. 255, that's /24. And in the other computer, let's say the PC6, just a different IP address from the same network, 10.0.0.20/24, so it's 255.255.255. Okay, done. So let's go to simulation mode and let's try to send an ICMP message. Let's try to send a ping from PC0 to the PC6. Just two configured computers. Okay, to send an ICMP message, we need to know the MAC address of the PC6. So we need to make an ARP request, and that ARP request is sent to the destination MAC address broadcast. That is the MAC address of the broadcast. So the switches will forward that frame to all the connected ports, in which will be one broadcast domain. So you can see that that message is spread to different computers. It reaches all the others. So the same message has arrived to all the computers, but just one of them has replied. So this is a broadcast domain. One ARP message is spread to all the computers in the network, even they are not configured. They have no IP address, but for the switch, there's something connected in that port, and the switch has sent the broadcast message to all the computers. Okay, so that's one huge broadcast domain. Now let's use one VLAN. For example, let's add another computer in PC1. Okay, we'll delete that message. We'll plug that one. Connect PC7 to the switch. Use an IP address from the same network. So it will be the 10.0.0.30, for example, /24 255.255.255.0. And now we'll try to send a message from those computers in the same switch. Simulation mode. Okay. Oh, sorry, we were in real time and not in simulation mode. So to try it again, have to go to that computer. Now ARP/A, I can see that I know the MAC address of both computers. I will delete the ARP table. So now in simulation mode, I will follow the path of that ARP request to the switch. It will reach the final device, but it will spread through all the broadcast domain. Okay, so let's change that back to real time. Let's delete that, and now we'll set up that switch and we'll put those two computers not just in one network but also in one VLAN. Let's say VLAN 10. Okay, so we go to the switch, enable, configure terminal. We should set up those computers PC0 and PC7 in the same VLAN. For that, we need to know to which port they are connected. So back to options, preferences, always show port labels. And now we know that in the switch, one is in the fast Ethernet 01 and the other one is in the fast Ethernet 03. So in this switch, we can go to the terminal and set up the interface fast Ethernet 0/1, saying that switch port is an access port, switch port mode access, and is an access port of the VLAN 10. The switch says that the VLAN does not exist and is creating that. We can see that the VLAN is created with the command do show VLAN. We've got the VLAN 10 with the name VLAN 00110, so it's VLAN 10, and we can see that the interface fast Ethernet 01 belongs to VLAN 10, whereas the rest of devices just belong to the default VLAN, and this default VLAN is the VLAN 1. In every router, the VLAN 1 is the default VLAN, and all the ports of the switch belong to that one VLAN, to that default VLAN. Okay, we have the fast Ethernet 01 in the VLAN 10. Now we have to add the other port. Exit interface, the other one is the fast Ethernet 0/3. Switch port mode access, switch port access, VLAN 10. Okay, now both computers are in two ports in the switch that belongs to the same VLAN, VLAN 10. Okay, let's go back to the PC0. Again, we'll delete the ARP table, no entries, and in simulation mode, we'll try to ping from PC0 to PC7. Like before, the ICMP request needs an ARP request for knowing the MAC of PC7. That question goes to the switch, and the switch sends only to the other computer in the same VLAN, in VLAN 10. So, just defining two ports in VLAN 10, we have reduced the broadcast domain. Now, the broadcast domain is just the one involving those two computers, nothing more. The rest of the network belongs to a different network domain, because now once you use VLANs, the network domain is just reduced to all the ports belonging to the same VLAN. And that's one of the reasons why we use VLANs, to reduce the broadcast domains and restrict the broadcast traffic just to the ports connected in one VLAN. Okay, thanks for watching.